Don Luke Electronics. The Alpha Geek, geeking out. If you go to bed at night without learning something new that day, your day is not complete. Luke Paquin, 1973. Project number 19, Time, Global Positioning System, Mk04. Global Positioning System, GPS. The Global Positioning System, GPS, is a satellite-based radio navigation system owned by the United States government and operated by the United States Space Force. It is one of the global navigation satellite systems, GNSS, that provides geolocation and time information to a GPS receiver anywhere on or near the Earth where there is an unobstructed line of sight to 4 or more GPS satellites. Obstacles such as mountains and buildings block the relatively weak GPS signals. A satellite navigation device, colloquially called a GPS receiver, or simply a GPS, is a device that is capable of receiving information from GNSS satellites and then calculate the device's geographical position. Using suitable software, the device may display the position on a map, and it may offer routing directions. The Global Positioning System, GPS, is one of a handful of global navigation satellite systems, GNSS, made up of a network of a minimum of 24, but currently 30, satellites placed into orbit by the U.S. Department of Defense. A satellite navigation device can retrieve, from one or more satellite systems, location and time information in all weather conditions, anywhere on or near the Earth. GPS reception requires an unobstructed line of sight to 4 or more GPS satellites, and is subject to poor satellite signal conditions. Today, most standalone GPS receivers are used in automobiles. The GPS capability of smartphones may use assisted GPS, AGPS, technology, which can use the base station or cell towers to provide a faster time to first fix, TTFF, especially when GPS signals are poor or unavailable. However, the mobile network part of the AGPS technology would not be available when the smartphone is outside the range of the mobile reception network, while the GPS aspect would otherwise continue to be available.
Now, the battery display here, Arduino zoom here, GPS, date and time, and now the switch here, rotary switch, and here the resistor for this. So it's good. This, the GPS here, and project here, play, time, date, receive, GPS receiver, and here for display, date and time, hardware for here, GPS receiver, and latitude, longitude, date and time, speed, altimeter, and the status, and the rotary switch. And that's it. Date and time, this and this. Display, look electronics, inversion, date and time, GPS, latitude and longitude, and date, time, and this in here, so it's good. This setup and here, and now is good. So information or this. So it's good. And here, time, date and time, speed here, and here too. Perfect. Set up for here, which is in this, time and date. And now for switch here. Okay. Date and time, GPS here, and GPS here. So it's good. And here. Perfect. Now the GPS here, battery, display, sparse-spun things plus zoom here, date and time, and now the rotary switch here. So this and resistor for the here. So it's good. Now the battery for this is good. Now it's good. Power here and ground. That's it. And perfect. Now power. And date and time for this. Latitude and longitude for GPS. And now nothing, because 2 or 3 minutes here, so wait for GPS. This is good for now the GPS for date and time too. Here speed and this, but now wait for the here latitude and longitude. So it's good. Now the GPS good. Now GPS date and time, but now the GPS is speed and speed. This before this is one, but here no, but here now speed no. And latitude is height, the here level for ocean. So me, what, 2 or 3 GPS, and see here is good. So is now good for here, but latitude and longitude and speed and here. Bye-bye.
Don Luke Electronics. Curriculum Vitae. Zoom. Patreon. Facebook. YouTube. Twitter. Pinterest. Instagram.